In this video, we'll talk about composite functions, their definition, how to evaluate them, and how to write rules for them. So first of all, what's a composite function? Well, given functions f and g, the composite function f of g, or f composed with g, is defined by this, f of g of x. Let's unpack that, and I want you just to figure and picture just your good old function machines. So all this right here means is to say if you want to evaluate f of g of x, you start on the inside and you first take your x and you plug it into g. And then some kind of output's going to come out, some y value, or g of x, if you will. And then you turn right around and plug that into f. And whatever comes out then, that's your answer. That's your f of g of x. So it's just combining into two functions in a certain order. So we're going to look at what that means with equations, with tables, and with graphs. So starting with equations, let's say we have these two functions, f and g, and we're going to find f of g of 3. So start on the inside. G of 3 is 3 squared plus 1, so that's 10. Now I'm going to plug that answer into f. So f of 10 is 32 when I plug into 3x plus 2. The order matters. So I did f of g of 3. Now let's look at g of f of 3. That means I start with f of 3, and that's going to be 3 times 3 plus 2, which is 11. Then I plug that answer into g to get 122. So not the same answer as when we did f of g of 3. Now sometimes we want to leave just a generic rule and not work with an actual number. So if we're going to find f of g of x, that means we plug all of g into f. So we're really doing f of x squared plus 1, which means we're replacing the x with x squared plus 1. So this becomes 3 times x squared plus 1 plus 2. And I could leave it there, or I could simplify it through to make it 3x squared plus 3 plus 2, or 3x squared plus 5. Just pay attention to your directions. And then let's look at the other order. If I were doing g of f of x, that means I have to plug f into g. So I have g of 3x plus 2. So in my rule for g, I'm replacing x with 3x plus 2. So I have 3x plus 2 all squared plus 1, which I'm not going to multiply out right now. So let's say we have tables. Just another way of representing a function. If I have g of f of negative 2, again, start on the inside, so I should start with my f table. So I need to find what f of negative 2 is. So here is negative 2, so f of negative 2 must be 9. So now I need to figure out what g of 9 is. So I go to my other table, and I find 9, so g of 9 is negative 6. So my answer here is negative 6. But maybe I'm going the other way. Maybe I want f of g of 8. So I've got to find g of 8 first. So look at my g table. So g of 8 is 4. So now I have to find f of 4. So that's over here, and f of 4 is 6. Now, graphs. In this particular example, our red function is f, and our blue function is g. Same idea. We're going to find g of f of 2. So the first thing I have to do is find f of 2, which means I have to look at my red function and figure out what is happening when x is 2. So if x is 2, if I go all the way up to f, it looks like y is 4. So f of 2 must be 4. Then I plug that into g. So I have to do g of 4. So I'm looking at my blue function now and saying, okay, what happens when x is 4? Well, here's 4. Apparently it's 5. So g of f of 2 must be 5. Starting with 2, plugging it into f, plugging that answer into g. One more. Say we have f of g of negative 2. So now I'm starting with the blue function. So when x is negative 2, it looks like g is negative 1. So I'm going to have to figure out now f of negative 1 because g of negative 2 was negative 1. So now I'm looking at my red function and saying, what happens when x is negative 1? Well, it looks like y is 1. So f of negative 1 is 1. So my final answer here is 1. So you're just plugging into one graph and then the other.